Okay, so I'm making this little video about our empirical formula lab, which if you've read or logged into today, you see I made a major mistake in that lab. uh, I lost second period's data, but I won't rehash that again. So for second period people that did not finish in class, I put a set of data that you will use. It's what we got out of seventh period, so you can use that data. So we'll have four groups with the same data, and that'll be fine. It'll just be the way we have to do it. Because sometimes people make mistakes, including us. But so what I'm going to do with this video is just kind of walk you through the data calculations. So as you scroll down in your lab, and you probably want to, I would do these on a piece of paper. And then I would do these on a piece of paper and then just upload a picture into this page or something like that to turn it in to show your work. You can see down here is the sample data that you will use if you did not finish your lab in second period. Everybody in fourth period, I'm pretty sure that everybody in fourth period finished theirs. But if you did not finish yours, you too will use this data. But I'm pretty sure everybody got to the end in fourth period and got theirs done. So that's good. But I know I had about four groups in second period who didn't finish. So y'all will use this data right here. Sorry about that. Maddie, hush. 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 All right, so here's your analysis of data. And we walked through this a little bit in class, but I want to take some sample data and walk through it a little more specifically, especially for those who may have been remote. So I'm going to use this Jamboard to do that with. So sample calculation number one, you had to determine the amount of magnesium that we used. So the amount of magnesium, to do that, you're going to take the mass of your beaker plus magnesium. And for my sample data, that is going to be 50.3070 grams. And we're going to subtract from that the mass of just the empty beaker, 0.1582 grams. So that gives us a mass of 0.1488 grams of magnesium. So that's the amount of magnesium that I had to start with before the reaction happened. So this is calculation number one. Mass of magnesium consumed. Actually, I'm sorry. This is not number one. Let me erase that. This is what we have to use to get to number one. Why can't I? There we go. So why can't I erase it? Here we go. So that's our initial mass of magnesium. Then to find the mass of magnesium consumed, we are going to take this number that I just got right here, 0. So this is number one, 0.1488 grams. And I'm going to subtract from that the mass of magnesium remaining after the reaction has been completed. So that is going to be 0.0819 grams of magnesium. And that's going to equal, for my sample calculations, that's 0.0669 grams. So this is number one. This is the mass of magnesium consumed. Okay, so you'll take these two numbers, mass of beaker and magnesium minus mass of empty beaker, gives us our initial mass of magnesium. Then you subtract from that the mass of magnesium that was remaining at the end of the reaction, and that will give you the amount of magnesium consumed. So if you're looking at your data, so we can see here is our initial mass of magnesium, if you're one of the many that have to use this data. And so this is the amount of magnesium after the reaction is finished. And so I'm just going to subtract those two numbers to get the amount of magnesium that I used or that was consumed. So to get the amount of magnesium that was consumed, I'm going to subtract this number here, this number from this number. Okay. All right. So let's move on to calculation number 2. Calculation number 2, you need to calculate the moles of magnesium consumed in the reaction. So I'm going to take my grams that were consumed. That was my 0 for my data, my 0.0669 grams of magnesium. Use my little railroad tracks, and I'm going to find the moles of magnesium that were consumed. Magnesium's atomic mass is 24.31 grams. That's supposed to be a decimal point. And that's in 1 mole of magnesium. So my grams are going to cancel, and that will give me 0.00275 moles of magnesium. Okay, and I get that just by, I multiply the top, so 0.0669 times 1 divided by 24. Okay, that is calculation number 2. Calculation number 2, find the mass of magnesium chloride produced in the reaction. The mass of magnesium chloride produced in the reaction. To find that, I'm going to take the mass of my beaker and the white powder residue that was left over that most of y'all did not get to see. So this is the mass of the beaker and the residue. And I'm going to subtract from that the mass of the empty beaker, 0.1582 grams. And so when I subtract that for this sample data, I'm going to wind up getting 0.2526 grams of magnesium chloride. This is why we learn how to write formulas, because formulas are quicker than writing names. But okay, so that is the grams of magnesium chloride that's produced. So if you're using sample data, I did that for you over here at the end. Okay, so mass of beaker, magnesium, and chlorine, and I subtract from that the mass of the beaker right here. And so this is the amount of magnesium chloride that was made 7th period. Okay, so that's calculation number 3. Calculation number 4. There we go. Now, come on. Calculation number 4 down here is to calculate the mass of chlorine or chloride in the magnesium chloride that was produced from the reaction. Okay, so I'm going to put this one right here. So for my data, what I'm going to do is I'm going to take this mass of magnesium chloride that I have right here, 0.2526, And I'm going to subtract from that the mass of just the magnesium that got consumed in the reaction, which is my 0.0669. And that's grams of magnesium. So if I subtract out the grams of magnesium, all I'm going to have left with is the grams of chlorine, which for this data turns out to be 0.1857 grams of chlorine, or chloride. Chloride has the negative sign there. Okay? So that's number 4. That is not done for you. Everybody will have to do that, whether using the sample data or your own data. You will subtract the mass of the answer you get from number 3. You will subtract that from the answer you get for number, what is that? 1. So you'll take your answer from number 3 and subtract from that your answer from number 1. Okay? So calculation number 5 is to record the number of moles of chloride that are in the magnesium chloride produced. So you're going to take your grams of chloride that you just found out in number 4. So this is number 5. We're going to take our grams of chlorine, 0.1857 grams of chloride, and we are going to turn it into moles. So in 1 mole of chloride, there is 35.45 grams of chloride. So that's going to give me 0.00523 moles of chloride. Okay? All right. So that is number 5. Number 6 says report your answers to your teacher. Class data will be collected for graphical analysis. This you do not have to do right now. We will take care of this Tuesday. If we see whether we even have enough data out of all 3 periods to do this, since I messed up. So number 6, you can leave that. So going down here, it says after completing the graphical analysis using class data, answer the following questions. What does the slope of the graph represent? So you can skip that. Number 2, determine the mole ratio of the magnesium to the chloride in magnesium chloride from your data. Okay, so in number 2, what you're going to do is you are going to take the moles that you found here and the moles that you found in number 4, and you're going to make a mole ratio out of them. So this is 0.00523. This, no, not number 4, sorry. Number 2, this is 0.00275. All right, well, number 2, this number is less than number 5. So we're going to divide this number into both of these numbers to get our mole ratio. Whoop, one too many pages. Okay, so I'm going to take my moles of magnesium, which was 0.00275, and I'm going to divide it by itself because it's the smaller of the 2 moles. And then I'm going to make this a ratio, so put my little dots there. I'm going to take the moles of chlorine, which was 0.005, what was that? 523, and divide it by the moles of magnesium. Okay, so this just cancels to 1. And if I divide that out, 0.00523 divided by 0.00275 comes out to be 1.92, which is pretty much 2. Okay, So my ratio is 1 magnesium and 2 chlorines. Okay? Because remember, this is my chloride ion. This is my magnesium. Okay? Now, yours may come out differently. That's fine. But what you want to do is you want to put this number is going to go right here, and then you're going to round it to the nearest whole number. So if it's 1.5 or greater, that's going to round up to 2. If it's not, then it'll round down to 1. So hopefully it'll come out 1 to 2, but it may not. That's what an experiment is all about. Okay. So should be about 1 to 2. So that's number 2. What is the chemical formula for magnesium chloride? Based on this ratio, we have 1 magnesium and we have 2 chlorines. So it should be MgCl2. What is the percent composition for magnesium and chlorine in magnesium chloride? Okay, so for that one, we are going to find, we're just going to do a percent calculation just like you normally would. You'll need to find the molar mass of magnesium chloride before you do that. Yeah, right here, number 5, calculate. Oh, I'm sorry, I read that wrong. Question number 4 says calculate your percent error, not your percent composition. I was looking down here at number 6. So to do percent error for a experiment, what you are going to do is you are going to take the actual value that you got, which is 1.92, and subtract it from the theoretical value, which is what you should have gotten, which would have been 2 in this case. And then you will divide it by the theoretical and then multiply by 100. Okay, so take what you get when you make your mole ratio, take what you get for the moles of chlorine after the moles of the mole ratio, subtract it from 2 because 2 is what you're supposed to get, divide that by 2, and then multiply by 100. Okay, and it is the absolute value of this number, so we're not worried about a sign. We just drop the sign off. So if these are your numbers, my percent error is 4.75%. Now, it should be a low number. It should be as close, your percent error should be as close to 0 as possible. But I've done this lab and gotten 50% error, gotten 60% error, especially if we had to stop the reaction early. That means it didn't go to completion, so you don't have as much product in there as you should have had, which is going to make your percent error very high. So if you get a high percent error, don't worry about it. I'm not going to count anything wrong. I just want you to do the calculation and correctly report what your percent error is. So again, don't get freaked out about it if you get a number that's like 50% or whatever. That's not what you should do. And in the real world, we would go back and redo this experiment, but we don't have time for that. So now, if you do get a number over 100%, then you did your math wrong. Okay, so be careful of that. All right, so that gives us number 4, calculating your percent error. Number 5, what is the molar mass? That you're just going to use your periodic table and add up the mass of magnesium and the mass of 2 chlorines. So that was going to be 24.31 plus the mass of 2 chlorines, which turns out to be 70.9. And so we add those together and we should get like 95.21, something like that. And this is how many grams are in 1 mole of magnesium chloride. So that's why we call it the molar mass. Number 6, what is the percent composition? So you're then going to take that number and find percent composition by taking 24.31 and dividing it by 95.21, and then 70.9 and divide it by 95.21. That gives you a percent error. Number 7, if given 100 grams of magnesium chloride, explain how the empirical formula of a compound can be determined from the percent composition data. Because if you're given 100 grams, you're going to assume, oh, here we go. So on this one, this would be analysis question or post-lab question number 7. So if we have 100 grams and we know our percent compositions are 25.53% and 74.47% chlorine, magnesium, then since these are in percentages and you're given 100 grams, all you need to do is take your percents off and put gram sign. So you can say that you have 25.53 grams of magnesium, 74.47 grams of chlorine, and then you would simply turn those grams into moles. So I'm not going to work this one out specifically for you, but on both of those, you're going to turn your grams into moles. And then divide both of these answers by the smallest answer, just like we did back here. Once you get your 2 moles, you will divide by the smallest mole, and that will give you your mole ratio. Should, again, come out to be 1:2. Okay. Then number 8 asks you for you to compare your data to the actual percent composition and see if that came out similar. And the percent composition should come out to be about the same. Again, if they don't, then we have some experimental error that's taken place, and we know that there was a lot of that just from the fact that we took a long time. Some of us had to stop early, and then your teacher loses your data, so that affects things too. So just answer honestly on number 8 is the best way to do that. Number 9 asks you, in this experiment, you are to remove the water by heating. So I'm on question number 9. Why do you have to heat it at least twice? So again, why is it better to heat it more than once? Instead of just heating it for one really long time period, why is it better to heat it 2 or 3 times like I told you? And again, that's just thinking about it and writing down what your opinion is and why you think that might work better. If you neglected to heat the beaker gently the first time and splattering occurs, how would this affect your results? And it says be specific. So I want to know my results would be, my mass would be too low or it would be too high, and then predict how that would affect the rest of your lab. Predict whether it would be too high or too low. Several trials were run in your class using different masses of magnesium with varying results. Actually, the ratio of magnesium to chloride should be the same for all the trials. Explain why this is the case. Do not simply state the mass percent is an intensive property. So you need to explain why everybody should be getting about the same ratio of magnesium to chlorine. Okay, on number 12, they're just asking you to work out that problem. It's an empirical formula problem, and you are given, and there are 2 separate problems here, you are given the percentages, and that's all you're given. So if all you're given is percent, then you're asked to find empirical formula. You're going to need to make that big assumption that you have 100 grams. And so then you're going to work it out just like you worked this one out. Okay? Right, what was the gas bubbling from the reaction? All right, so we put that on the board during the class. We said, let's do it this way. So in our reaction, we had HCl, was our acid. We had magnesium metal, and law of conservation of matter and energy says I have to end up with those three things, not arranged in that order, but I have to end up with those three things. So the bubbles have to wind up being hydrogen gas, and then the only other two things that are left are these two things, and that's going to be magnesium chloride. Okay. Um, Write a chemical equation between the magnesium and hydrochloric acid. So I just did that. That was number 14. Number 15, based on your observations, what reactant is the limiting reactant? You do not need to answer number 15. Okay, do not do number 15. Limiting reactant is just which one do you think ran out first? Actually, you know what? Let's go ahead and do it. Tell me which one of these do you think ran out first? The magnesium or the hydrochloric acid? That's what a limiting reagent is. So just give me your best guess. There's no right or wrong answer. You do need to explain why you chose that one, though. Okay, 16. Magnesium is a metal. Describe the magnesium atoms in a solid magnesium in terms of the number of protons and electrons and the net charge. Identify and describe the bonds between the atoms. All right, so since magnesium is a metal, I want you to tell me how many protons it has, how many electrons it has, and what will be its charge. Okay, what's the charge of its ion? Is it a +2, a +1, based on where it is on the periodic table? Identify and describe the bonds between the atoms. Well, if it's a metal, then the bonds are going to be metallic. Okay. 17, compare and describe the magnesium in the reaction to magnesium in the product. Okay, so this one is just asking you why are they different? Is the magnesium metal different from the magnesium ion that's in magnesium chloride? And yes, it would be different. So the bonding is different because in the magnesium metal, it's metallic bonding. When it binds with the chloride or the chlorine, it becomes an ionic bond. Did the magnesium gain electrons or lose electrons? So it went from being magnesium to being magnesium 2+. Is that gaining electrons? Is that losing electrons? Write a chemical reaction showing only the magnesium in the reaction. So to do that, you have magnesium with no charge at all because it's a metal, and then it is turning into magnesium 2+. Okay, and to do that, it is going to lose 2 electrons. Okay, because that's what magnesium wants to do to get its full octet. And so it will give up those 2 electrons. Compare and describe the chloride ion found in hydrochloric acid as a reactant and in magnesium chloride as a product. All right, so looking at the chlorine then. Here, the chlorine is a chlorine ion because it's attached to that positive hydrogen there. And over here, it's still an ion. I just have 2 of them. It didn't change at all. Combine the half reactions written in previous equations to show the net ionic equation for the reaction between magnesium and hydrochloric acid. And how does this equation better represent what's actually taking place? All right, so I'm going to help you out with that one too. So net ionic means HCl, when it's dissolved in water or mixed with water, which it was, because it wasn't the most concentrated kind, we dissolved it in water. So it splits up because it's a strong acid. So it splits up into H+ and chlorine minus. And then we have the magnesium. And we end up with hydrogen gas plus your magnesium chloride dissolved in the water. That's why you couldn't see it at first. That's why we had to boil all that water off. So it became magnesium +2 and 2 chlorines. So I have to have 2 here and 2 here. There. Okay. So I have chlorines on both sides. And since I have chlorines on both sides, they cancel out. Okay. Just like in math, when you have the same number on both sides, it cancels out. So the actual equation is going to be the hydrogen ion plus the magnesium goes to magnesium 2 plus and H2. Those are the things that actually change in the reaction. The chlorine's still there. It's on the left side and on the right side both. So it's still there. It didn't change. But these are the only things that actually changed. Okay. So that was number 20. Number 21, draw the Lewis structure. Y'all can do that. I'm not going to do that one for you. 22. All right, on 22, it says stop here and wait on teacher's instructions. All right, 22, what you're basically doing is the same lab that you did, you're going to do again. You're not going to literally do it this time. You're going to use this data, okay? So William weighs an empty beaker and find it has a mass of 95.83 grams after putting a spoonful of magnesium chloride hydrate into the beaker. So he's not putting magnesium metal. He's putting the magnesium chloride in there. He finds the mass increased to 99.87, which it should increase. He added something to it. He heats the beaker and its contents twice and finds that mass has dropped to 97.61. William is told by his teacher that the molar mass of anhydrous magnesium chloride is 95.21 grams. What is the mass of hydrate did William start with? So again, the hydrate is the magnesium with water attached to it. Even though you may not see it, it's still there. And then you have to boil that off. So you're basically going to do the same thing that you did before. Okay, so I think I'm going to let y'all, since I've explained this once, I'm going to let y'all work on that and see what numbers you come up with. Okay, when you get down here to naming the hydrate is you're going to indicate how many waters are attached to that magnesium chloride with a prefix. So if you have 2, that would be bi or di. If you had 3, that would be tri. If you had 4, that would be tetra. If you had 5, that would be penta. So you're going to tell me how many hydrogens there are with by the prefix. Okay. All right. And as you go through and do these calculations, it's going to get you to figuring out how many waters were attached to this magnesium chloride in the first place. Okay. Remember, we are not doing the elaborate section. We have definitely run out of time on that one. We will come back at Tuesday and do the class data and get the graphical analysis of this. And also on Tuesday, we'll talk about how I want you to write up your lab report. Okay. All right. So I will be changing the due date on both this lab and the lab report. Okay. So if you have any questions, jot them down. Make sure you join the Google Meet on Tuesday so you can get all this information that you'll need. All right. That is it.